Hey guys, Bro Who Codes here, and today we're doing LeetCode 121, best time to buy and sell a stock. Let's get into it. You're given an array prices, where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Let's take a look at a couple examples. So this first array has numbers 7, 1, 5, 3, 6, 4, and the answer is 5. The answer is 5 because if we buy the stock at index 1 when the price is 1, and we sell the stock at index 4 where the price is 6, we make a profit of $5. In this second example, we have 7, 6, 4, 3, 1. And the answer is 0. The answer is 0 because as you go through the array, the price of the stock continues to drop. So there's no way that you can make a profit. A very intuitive way of solving this problem is to generate all pairs of prices that we can buy and sell this stock at. What do I mean by that? Well, since we know we need to buy the stock on a certain date and sell it on a different later date, we can generate every single pairing of stock prices and calculate the max profit that we can get by recording the profits we get from each individual pair. So if we check every single pair of stock prices, we'll eventually end up finding the pair that generates the max profit. In this case, it's value 1 at index 1 and value 6 at index 4, which creates a profit of 5. So we can do this exact same thing with this second example. So we can generate every pair of stock pricings so we could see which buy and sell price is the best to generate the maximum profit. And since all the values of this array decrease, we never actually generate a profit. Every single pairing of stock prices that we make generates a negative number when we subtract the buy price from the sell price, meaning that we never make a profit, meaning that we should return 0. So let's go ahead and code the solution. So we know we want to keep track of a variable called max profit. We want this variable to start at 0. And then we want to have a for loop that iterates over all values of the array. We'll call that value I. That'll be our buy price. That's the index of the buy price. And now we want to figure out the index of the sell price, which will be every value to the right of this buy price index. So we'll have a nested for loop inside of this for loop representing the sell price. The sell price will start at I plus 1, which is the first index after the buy price, the first place we can sell the stock. We'll do the same thing here. We'll increment it every single time we iterate over the for loop. So now that we have the index for the buy price and the sell price, we can keep track of the profit. We can calculate the profit from these two indexes and see if it's greater than the max profit that we recorded so far. So what we'll check here is to calculate the profit, first of all, which will be prices J, the sell price, minus prices I, the buy price. And we want to see if profit of this pairing we have, if that's greater than the max profit, then we want to set max profit to profit. And that's basically it. At the end, we just return max profit. The time complexity of this solution is n squared. The reason why is because the outer for loop iterates over every single value of the array to find a potential buy price for the stock. That is of time complexity n, right? Because at most we might iterate over the entire array to find the buy price. And for the inner for loop, we'll iterate over all the values to the right of the buy price that we've selected, which at most can be n minus 1 values. And if you multiply those together and remove the constants, you get n squared. The space complexity is constant because we only use a primitive int value to store the max profit. We don't use any other data structures. So it can actually improve the time complexity of this problem by a lot. So if we sell a stock, we would have wanted to have bought the stock at the smallest price possible so we can maximize the profit. So why don't we just keep track of the smallest price of stock that we've seen so far? So in the beginning, we can set that price to infinity. And as we iterate through, we can update it. So look at the first value. 7 is less than infinity. So that's the smallest value we've seen so far. 1 is less than 7. So 1 is the new value, the new minimum value. 5 is not less than 1, which means that we can make a profit. 5 minus 1 is 4. The profit we've calculated is 4. So that is our new max profit. So we keep going. 3 is also greater than the minimum value so far, so we can make a profit. 3 minus 1 is 2, but 2 is not greater than the max profit we've calculated so far, so we continue. So we see 6. 6 is greater than the minimum price we've seen so far, so we can make a profit. 6 minus 1 is 5. 5 is actually greater than the max profit we've seen so far, so we update our max profit. We keep going. 4 is greater than the minimum value we've seen so far, which is 1. So we can make a profit. 4 minus 1 is 3, but 3 is not greater than the max profit we've calculated so far, which is 5. So we continue, and now we're done, which is why the answer is 5. Same exact thing with this bottom example. So first value is 7, which is less than infinity. That's the new minimum value. Next value is less than 7, which is 6. 6 is the minimum value. Now 4 is the minimum value. Right? Now 3 is the minimum value. And now 1 is the minimum value. So we actually never calculated a profit that was greater than 0. The profit is 0. Because at every single index, the minimum value we had seen so far was that value at that index. Right? So the value of the max profit we can make is always 0. Because when we subtract the sell price from the minimum buy price that we've seen so far, we always get 0. 7 minus 7 is 0. 6 minus 6 is 0. 4, and continue on. The answer is 0. So let's go ahead and code the solution. So we want to keep track of the min price, which, like we said, we're going to set to the max value, which is like 1 billion. So a really high number that is unrealistic for this problem. And the max profit is going to be started at 0. And then for each value in the array, so we create a for loop, int I equals 0, I is less than prices dot length I plus plus. We want to check to see if the price that we're looking at is less than the min price that we've seen so far. So we want to do an if statement, which will say if min price is less than, if prices of I is less than min price, then that means we want to update the min price. So you want to say min price equals prices of I. So if that's not true, then that means we can potentially make a profit, which means we want to have another if statement here. Else if the price of the value we're currently looking at, prices of I, minus the min price, so that's the buy price, right, is greater than the max profit we've calculated so far, then we want to set that max profit to be this value. So it'll be prices of I minus min price. And that's it. And at the end of this for loop, we want to return max profit. So the time complexity of this approach is O of n. That's because we only iterate over the length of the array, which is n. We only iterate over that array once. So the time complexity of that is O of n. And that's it. The space complexity is also constant because we only use primitive values to store information. We don't use any data structures. Thanks for watching. I'm Bro Who Codes. If you found this video useful at all, please leave a like and subscribe for more content. That would mean the world to me. And leave a comment below about any questions you had about this problem or anything you want to see next. I would love to see what you guys have to say. And anyway, appreciate you guys. I'll catch you later. Peace.